Alrighty, hi there, Addy. Welcome to lesson number 67. We are moving right along here. And this lesson is going to be super fun. But the first thing that we're going to do is your facts practice. So get out your facts practice, and you are going to, looks like you're going to be writing mixed numbers as improper fractions. So you're going to get some practice doing that, and you're going to have 5 minutes of practice. So you ready for that? Here we go. On your mark, get set, go. Good job, Addy. Keep going. You got this. Good job, Addy. Hang in there. You're doing awesome. Awesome. Okay, we are going to stop right there. At least if you haven't fallen asleep from that relaxing music. Man, whew, that was relaxing. Alrighty. Now, let's talk about this comic first, The X Factor. And there's an equal sign, there's a number 1, and he's saying, uh-oh, don't look now, but here comes your X. Oh, here comes the X. Like, here comes your X. Oh, man. That's funny, huh? That has a double meaning for sure. Alrighty. Let's try and jump into mental math. Excuse me. We are going to count down by 2s, starting with 10. And guess where we're going to end up this time? -10. Woo! So that's really going the extra mile, okay? Let's see if we can do it. We'll start with 10, 8, 6, 4, 2, 0, -2, -4, -6, -8, -10. Whoa, that was cool. Okay, that was so much fun. If you want to do it again, you can pause the video there and do it again because that was just so much fun. I don't blame you if you want to do it again. Alrighty, I gave you some wonderful cloud pictures to look at while we go through these mental math problems today, okay? We're going to start with 5 times 260. Write your answer. B is 341 minus 50. Write your answer. C, 3 times 48. Ooh, that seems tricky. I want to know how you do that one, Addy. Let me know how you do it. Okay, D, $9.25 minus 75 cents. What do you get? This picture of the clouds is cool because it looks like you're looking at them from above, like up in a plane. E, we are going to double $1.25. Write your answer in the clouds. We're going to double $1.25. And F, we are going to take $30 and divide it among 100 friends. $30 divided among 100 friends. What do we get? What does each friend get? Not all that much, huh? G, those clouds are so cool that it looks like a river to me, or like an ocean. Okay, we're going to start with 6 times 6, all right? 6 times 6. Now we're going to subtract 1. Divide by 5. Multiply by 2. Add 1. Divide by 3. And divide by 2. What do you get? All right, now for H, we are going to hold our hands a foot apart and then 9 inches apart. Whoops, 9 inches apart. Okay, I'll give you a clue here. If you hold your hands about a foot apart, that's a little bit longer than the long side of your piece of paper, right? So if this is your piece of paper, here I'm going to draw your piece of paper. Let's get a color you can actually see. Okay, I'm going to draw your piece of paper. And you've got your holes here maybe, and you've got a piece of paper like that. If you hold your hands 1 foot apart, it's a little bit longer than this length. And then if you hold them 9 inches apart, it's a little bit longer than that length. So did you go from big to small or small to big, or what'd you do? All right. The next one is problem solving. Ooh, look, doesn't that look delish? Ooh, it's making me hungry. Problem solving is about spaghetti. That's why I put that there. So the problem tells you that in a pound of spaghetti, you've got about 520 noodles. And each noodle is 9 inches long. Okay? So now let's read it. There are about 520 9-inch long noodles in a 1 pound pack of spaghetti. If we place them end to end, how many feet would that be? Whew. Okay, so that means you take out a piece of spaghetti, right? I'm zooming in on your piece of spaghetti like that. and you place it on the ground. And then you put another piece of spaghetti right next to it so they're touching. And then another piece right next to it so they're touching. So this is 9 inches from here to here. And then this is 9 inches. Then this is 9 inches. Okay, so they have about 520 of these. So how many feet would that be? And they want the answer in feet. So you might, with the number 9, be able to figure it out in inches, but then you'll have to figure out how many feet that would be. Okay? So I'm going to let you do that. And you're definitely going to have to pause it there because that's going to take a while, because I have a feeling that is going to be a huge distance, like a huge number of feet. All right, the new concept is so fun. It's going to be a cool way to reduce giant fractions, big giant fractions, like monster fractions, okay? Like big numbers in the fraction. And this is going to be a cool way to reduce it. And you know how cool I am. This guy, when I watched this episode, I thought, man, that guy is so cool. And I was like, I'm going to learn how to roller skate because I want to be as cool as this guy. And you know what? I think I might be almost as cool as that guy. So if you want to be cool too, you're going to love this way to reduce giant fractions. And this is how we do it. This is going to be so fun, okay? Let's say you have a giant fraction like this. And obviously that's not simplified down to its simplest form, because this can be divided by 5, and I know this can be divided by 5 because of the numbers that they end with. So how can we reduce it down, especially when the number is humongous? Well, the answer is prime factorization. Oh yeah, that came back to haunt us, huh? Prime factorization. This is so fun. Okay, so the first thing we're going to do is we are going to start with the numerator and prime factor it. Oh yeah, prime factor it. So you can do it with the tree factor way, or you can do it with the division by prime. Let's do, what do you want to do? Let's do the division by prime. Okay, so that's where we stack the boxes. Let's try it. So I'm going to put 125 down here. And then I'm going to pick my lowest prime number that can go into that. Now, it's not going to be 2 because that is not an even number. Could it be 3? Maybe. Let's add the digits. If we add the digits, 1 plus 2 plus 5, you get 5, 6, 7, 8. You get the number 8. And did you know that if you add the digits and that number that you get, if that's divisible by 3, then the whole thing is divisible by 3. That's a nice little trick to keep in the back of your mind. But 1 plus 2 plus 5 makes 8. It doesn't make 9. So this is not divisible by 3. But I do know it's divisible by 5 because of that number 5 there. And 5 is a prime number, so I'm going to go ahead and put a 5 out here. So how many times does 5 go into 125? Let's see. I'm going to make another box and put the next number up there. And what is it? I need my calculator. Well, 5 goes into 12 twice with 2 left over. It's 25. Okay, so it's 25. 5 times 25 is 125. You probably could do that in your head. Now, what's another prime number that goes into 25? Well, 5 times 5 makes 25. And those are both prime numbers. So now these are all prime numbers. So that is my prime factorization for 125. So I'm going to write that here. Okay, I'm going to erase this, erase it, erase it, erase it, erase it, erase it. And I'm going to put 5 times 5 times 5. That's prime factorization. Okay, easy peasy. Now we've got to do that for 1,000. Whew, we can do it. We can do it. It's not that bad. Let's do the box method again. I'm going to get a different color so it's not confusing. 1,000. I'm going to write it down here. Now, 1,000 is an even number, so I know 2 goes into it. And if 2 goes into 1,500 times, right? Sweet. Now, I can divide that by 2 again, right? So 500 divided by 2 is going to be what? 250. All right. And 250 that's another even number, right? So we can divide that by 2 again. What's 250 divided by 2? It's going to be 125. Okay, I'm going to keep going. 125. Now I'm a little bit stuck because 2 does not go into that number. What's my next prime number? 3? Does 3 go into it? No, because if I add 1 plus 2 plus 5, I get 8. 3 doesn't go into 8, so 3 doesn't go into this number. What about 5? Yes, 5 goes into it because look at that. Okay, so I'm going to put a 5 here. How many times does 5 go into 125? Well, we did that on the last one. We figured out it was 25. Ooh, I got to make some more space here. All right, and then 25, I can break that down to 5 times 5. All right, so what are my prime numbers? I've got a 5 times 5 times 5 times 2 times 2 times 2. Whew, okay. 555-222, like a phone number. 555-222. 555-222. I've got to remember that because I'm going to erase all this, and then I'm going to go 555-222. It's like a phone number. Okay. Now, this is what's cool about this. Now that I've got the numerator broken up into its prime and the denominator broken up into its prime, anything that is the same on the top or bottom, I can get rid of it. Why? Because 5 over 5 is the same as 1. It's like a fraction that means 1. So instead of 5, you've got a 1 there. Okay? So what I'm going to do, I'm going to use a different color. Let's do like a green. Okay. So if it is the same on the top and the bottom, oh heck, I didn't mean to erase that. There we go. If it's the same on the top and the bottom, I'm going to erase it. I'm going to get rid of it. Cancel. This 5 cancels this 5. This 5 cancels this 5. This 5 cancels this 5. And what am I left with? I'm left with 1, because if you cancel everything, you're just going to have a 1 on top or on bottom. And then on the bottom, I have 2 times 2 times 2. So that reduces to 1 over 2 times 2 is 4 times 2 is 8. So 1 over 8. So this is what's cool. 1 over 8 is the simplification for 125 over 1,000. That simplifies just to this. Yeah, is that cool? We figured it out. 125 over 1,000 simplifies to this. Bam! That was fun. So all you do is you prime factor it, prime factorization, and then you cancel out things that are the same on the top and the bottom. Let's do another one. That was so much fun. We're going to do another prime factor. Prime factorization is like mind manipulation or hypnotizing someone, right? That's why I put this there. But you know what? It's super distracting. So it's pretty, but distracting. I'm not going to do that. Alrighty. So we want to reduce this guy. Whew, another monster of a fraction. 375 divided by 1,000. Okay. Do you want to do it a different way this time? Let's see. We could do it a different way this time. Let's, like the tree way, maybe? We could do the tree way. I don't know how to do that with 375, though, because I don't know. I can't think of 2 easy numbers that multiply to make that. Let's do the box way for this, and then the tree way for the bottom. Okay, so we'll do it 2 ways. Let's start with 375. I'm going to put it way down here, so that's the bottom box. Okay, I know 5 can go into it, right? So 375 divided by 5. So I'm just going to use my calculator for that, and I'm going to get 75. Okay, now what goes into 75? Well, 5 goes into it again because you've got that 5 on the end, and that makes 15. Ooh, 15, I like that one because you can just do 3 times 5. And then I'm going to circle all my primes. 5, 3, 5, 5. Those are all my primes. So that's the prime factorization for 375. So on the top, I'm going to get 3, let's do the 3 first, times 5, times 5, times 5. Okay, sweet. So that's my new numerator. Instead of 375, I'm going to put that. Now, 1,000, I've got to do the, break that down into primes. So I'm going to do the tree way, 1,000. So let's see. What is 100 times 100? No, it's 10,000. 100 times 100 is 10,000. So you could do like 100, if you break this down, make a tree out of it. Let's make a tree. You could do 100 times what? It would be times 10, right? Because you're just adding another 0. So 100 times 10, those are not prime numbers. So I got to break that down even more. Okay, so 100 can be 10 times 10, 10 times 10, okay? And 10 can be 5 and 2. Okay, so those are primes. I'm going to circle those because I know these are primes. So that ends the branch once you get to a prime. But these 10s can be broken down further. So I'm going to break this 10 down. Whoops, that's all right. I didn't turn it brown, but it's okay, whatever. And then this can be 5 and 2. And this can be 5 and 2. Okay? So those are primes. So I'm going to circle all of those, and that ends the branch. Okay, so this is what we have for primes on the bottom. Whoops. Oh, I know. Okay, stop. I don't know what I just did there. That was an accident. Oh, poop. Okay. Okay. I'm messing up the video. Sorry. All right, here we go. So 5, 2, 2, 5, 2, 5. So that's what I have on the denominator because that's what I broke down 1,000 into, okay? So let's get the 2's in place. So I'm going to use a different color so it's not confusing. You have 1, 2, 3 2's. So it's going to be 2 times 2 times 2. And then I have 5 and a 5 and a 5. 5 and a 5 and a 5. Okay, so let's erase this. And this is my new fraction. So this is cool. This is my new fraction right here. So I did prime factorization of this fraction and I got this. Now all we need to do is cancel what is the same on the top and bottom. This 5 cancels this 5. This 5 cancels this 5. This 5 cancels this 5. So what I'm left with is 3 on the top and 2 times 2 times 2 on the bottom. So 2 times 2 is 4 times 2 is 8. So what I'm left with is 3 over 8. So this is so cool because this big old monster fraction reduces to that. That's it. An easy way to do it. I love it. So fun. Prime factorization. And now guess what? That was so easy peasy lemon squeezy that it is your turn to go practice everything you learned, okay? Good luck doing your math today, Addy. Love ya. Have fun. Enjoy it. Bye.